Hello everyone! I noticed another mistake about temperature markets. How do people generally work with models on Windy? Usually, when comparing these models, people talk in simplified terms. If they match, we enter. If they differ, we skip. But that's a black and white approach to a question that is actually measured in gradations. Today we'll look at how to turn the spread between models into a specific numerical probability estimate, rather than just a simple yes or no signal. The idea is simple. The more independent forecasts agree with each other, the narrower the actual range of possible outcomes, and the closer the estimate is to a probability of 0 or 100% for a specific threshold. The wider the spread between the models, the higher the probability of being somewhere in the middle, closer to 50%. The task is not just to look at two numbers, but to assess where the market threshold is relative to this spread. We use the same three sources, that's Windy, Wizard.gov, AccuWeather, and of course the historical Wizard API. Windy provides access to several models Yes, as we can see, we have a lot of models here. We use the European, the American, as well as the runs of both models. That is, we run the European model, look at how things change, where the peak is, and where, on the contrary, the lowest temperature is. We also take the American model, run it, check it, yes, set the exact point, see which point we need, run the model, look at what temperature we have, at which time interval, at which specific hour, and compare it with the European model. If you look at the detailed layers, this allows you to see not just two numbers, but a whole cloud of possible temperature trajectories. Yes, here we see the trajectories of our cold and warm fronts. That doesn't matter, just the possible temperature change trajectories. And Wizard.gov gives us an additional official forecast indicating the confidence interval where it is published. The comparison between the European and American models here is used not as a binary filter, but as 2 points on the range of spread, and the distance between them is directly converted into the width of our uncertainty. The logic of the break is simple for us. Let's imagine the market threshold is between the values of the two models. For example, one model shows 31 degrees, let's say, and the other shows 34, while the market threshold is 32.5. In this case, the formal rule of models agree or disagree doesn't work. The models literally diverge exactly around the threshold. Here, a reasonable probability estimate is close to 50%, and there is no advantage, no advantage for the market, regardless of what price it offers us. Another situation, both models show a value above the threshold, and the difference between them is only half a degree. Then the entire spread lies on one side of the threshold, and the probability estimate can confidently approach 90–95%. It is precisely the distance between the market threshold and the center of the model's spread, divided by the width of this spread, that gives a more accurate numerical estimate than the intuitive the models. The gap we are looking for is a situation where the market price clearly does not correspond to this numerical estimate. For example, the market gives us 50 cents where, according to the spread of models, the probability is valued at 85%, or vice versa. This approach requires precision. If you have access to only two models, rather than a full ensemble of runs, the probability estimate will be rougher than you would like. Treat it as a guideline rather than an exact number. Also remember that the spread of models can narrow or widen as the date approaches. Reassess the probability closer to market close, rather than relying on a calculation from a week ago. This is very important. Let's run through some event as an example. Kuala Lumpur, June 21st. Will the highest temperature be 32 degrees Celsius? We bet on no. We are back in the city of Kuala Lumpur once more on the 21st of June. June 21st. We click on history, June 21st, Kuala Lumpur, Malaysia. And we see that 86.4 is actually the highest recorded temperature across all of Kuala Lumpur. Here the reading is 85.5 degrees, which overall provides us with a significant amount of confidence that there really could not have been a temperature of 32 degrees at that time. The highest average temperature we have recorded in July is 31 degrees, specifically in June. Accordingly, we can just look here as well. Kuala Lumpur. Well, we obviously don't use WizardGov because that's for America. Kuala Lumpur, on the other hand, is in Malaysia, of course. And on Windy, everything basically comes from Windy.
Okay.
What signal Windy gives us, how we use it as a reference, how we use it in general. And that's why I started this video in the first place, because people don't understand that just comparing two models isn't enough for a 100% forecast, a 100% analysis. We need other tools as well. So we need June 21st, 34 degrees. So we can clearly see that we have answered with a definitive no. After we carefully analyzed it, we found that we have 86 degrees Fahrenheit, or 85, let's just say 85 for now. That is significantly higher than the specific value that the market gave us, which we determined just by carefully comparing, looking at the data, thoroughly analyzing the numbers, and finally drawing a logical conclusion. The key idea, the agreement or disagreement of the model, is not a traffic light signal, but rather an action that can be turned into a specific numerical probability, and a trader who knows how to do this gets a more precise tool for comparing with the market price than someone who simply asks, do the models agree or not? Subscribe to analyze more of these quantitative approaches. See you